Hi, everyone, and welcome to the MLOps Live Webinar Series. We're really thrilled to see so many of you with us here today. We've got a great session coming up on industrializing enterprise AI with the right platform. And this session, as you all know, is all about operationalizing machine learning and bringing data science into real business applications. Today, we're delighted to have with us Tony Paikaday, Senior Director of AI Systems at Nvidia, and Yaron Haviv, Iguazio's co-founder and CTO. Tony is responsible for the go-to market for Nvidia's DGX portfolio of AI supercomputers and Nvidia's accelerated machine learning platform for enterprise. In his role, Tony helps enterprise organizations infuse their business with the power of AI, with infrastructure solutions that enable insights from data. Yaron is a serial entrepreneur who served in multiple CTO roles before starting Iguazio. He is also the creator of Nucleo, a leading open source serverless platform with over 3,400 GitHub stars, and MLRun, Iguazio's open source pipeline orchestration framework. Today, we're going to be discussing industrializing enterprise AI, considerations and best practices. We'll deep dive into the challenges of enterprise AI. We'll discuss when you should deploy on-prem and when you should deploy on cloud, and which is better in which situation. We'll talk a bit about elastic AI infrastructure with DGX A100, and we'll discuss strategies for operationalizing machine learning and streamlining your data science workflow. Later, we're going to go into a demo of real-time intelligent financial market analysis, and of course, we'll leave plenty of time for questions at the end. There is a Q&A panel at the bottom of your screen, so feel free to write any questions you might have during the presentation in that area. We'll be running 2 polls during the session to hear more from you and see where you stand on the different topics raised here today. We've now put everyone on mute, and we're recording the session so that we'll be able to send it to you afterwards. Before we dive in, we also invite you to join our MLOps Live community on Slack, and we'll be sending a link around momentarily. So do join us there to continue the conversation. And without further ado, I will pass it over to Yaron.
Okay, thanks, Sahar, and thank you, Tony, for joining us. We're happy to listen to your presentation, a lot of enlightening data points. Before we dive into that, and later on I'll come back and show you a pretty cool demo that is using GPUs and doing real-time analysis of market data. Let's understand what are the challenges that we're facing and why do we really need the MLOps. The biggest challenge for most organizations today is moving from a research environment where you develop models, you play with static data or extractions of data, into real-time pipelines where you actually incorporate data from a variety of sources. You run training and machine learning at scale, you run preparation at scale, and you run serving and deploy everything into a real business application. And what MLOps is about is really trying to ease that transition and automate the process of moving machine learning from sort of the lab environment into something that could serve the business and real and operational applications. And with that, let's move into Tony, and he's going to explain to us the key challenges and how you might solve them.
Tony, over to you.
Great, thank you so much, Sahar. And I want to thank the Iguazio team. We value the partnership with Iguazio, the strategic partner for us in helping organizations scale AI, and as you see here, industrialize the development of AI. So we value the relationship. Thank you for having me on today. And let's go to the next slide, please. So to start things off, I guess I want to recognize that clearly we're in challenging times, and many of you today might find yourself facing unprecedented pressures and even some existential threats potentially. But for seasoned leaders, this may not be that new. And if you look back many decades, you'll see similar inflection points that challenged businesses. And during these times, well-managed organizations that survived consistently did 3 things really well. They drew customers closer, solidified relationships, customer experience and loyalty, They intently focused inwards on ways to streamline processes and save costs everywhere possible. And I guess third and final, they position themselves for the upturn, using the current situation to invest in enabling better business agility and outmaneuvering the competition. And I guess the remarkable thing here is that AI is well poised to help in all three of these areas. So let's go to the next slide. Many of you have probably been inundated with, the AI hype cycle and stories of like robotic butlers and flying cars and things like that. But the reality is that there are a lot of practical AI use cases that are perfect for surviving and even thriving in challenging times. And if you think about it, now is a great time to implement recommender systems to deliver more personalized experiences for your customers, and tailored support with natural language processing and AI chatbots. Now is a great time to reduce inventory levels and improve forecast accuracy to save money. It's also a great time to anticipate customer behavior and intercept churn. In reality, AI is adept at finding the needle in the haystack and distilling oceans of data into actionable insights that you can use to put yourself ahead of the competition. So, times like these are really when leaders double down to create unfair advantage. The question is, are you in a position to capitalize on this AI-fueled transformation? Now, as we'll see on the next slide, the challenge is that many enterprises know they need to do this, but not all know how to get there. And in this study, it was noted that while the vast majority of business executives knew that their future was tied to embracing AI, over 3/4 of them didn't know how to take advantage of AI and scale it effectively across the business. So, in today's session, we'll hopefully give you some guidance that'll help ensure that you don't find yourself in the 76% shown here. So I guess, why do many find themselves stuck? And let's look at this in the next slide. To understand why AI success can be elusive, we need to look at what happens in most businesses. And for me, this tweet kind of summarizes it perfectly. I've been using it previously because I think it captures it so well. I think many organizations hire data science talent with an expectation that answers and applications will soon come, and thanks to this much sought after expertise, answers will soon follow. But when you look at the sweat equity that's plowed into all the work involved in AI model development, you find that many organizations are incurring a growing amount of model debt. And what I mean by that is the investment in resources sunk into undeployed or even underdeployed AI models. Too much great intellectual capital never makes it past these prototype phases into production. So I think there are a number of reasons for this, and let's get into a few of these on the next slide. The reality is that AI models are not developed like conventional software. It's resource-intensive work done by data science artisans, people who are hard to find, expensive to hire, difficult to retain, and whose output is largely opaque to anyone who wants to explain how a model actually works, who's not a data scientist. These folks love to experiment, work with algorithms. Many of you are among this group, but they're not necessarily software engineers. There's a distinct difference there, and many might find themselves disconnected from IT or often operating outside of normal IT DevOps practices. So while data science competency may help you get to a great model, it won't necessarily help you see it into production. And I think what we're trying to do today, and especially the partnership with Iguazio and Nvidia, is we're trying to improve the end-to-end AI lifecycle from development to deployment, from something that's highly artisanal to one that's fairly industrialized or mechanized, one that's accelerated and actually integrated into a standard enterprise IT operation.
So Tony, one question, you mentioned silos. So what kind of silos do you see, and why do you think they arise actually?
Yeah, it's a great question, Yaron, because I think with a lot of organizations, there's an expectation of hiring, what I might call full stack data scientists. A friend of mine recently used this term, and I think it's kind of apt because there's maybe this expectation that a data scientist can roll into all these other disciplines like analyst, data engineer, experimenter, app developer, all rolled into one. And I think that's a great idea aspirationally, but it's impractical for many organizations that want to scale AI, as we're going to learn through what we're talking about here. We would go into an organization, an enterprise, and see multiple business units, each standing up their own ML development projects, but none of them aware of what these other business units were up to. So you'd have this repetition of infrastructure and platform and expertise, but each one completely kind of isolated from the other. And it was having a number of negative impacts in terms of, obviously, cost of operations, capital spend, lack of best practice sharing. And all of this was a symptom of essentially lack of adequate IT platform and resources, which would have, in a normal environment, been centralized such that everybody can use it. And,
Right, but
we have a
I
name for this.
think
Yeah,
that
go ahead.
I think that one of the points that actually how data science started is by having analysts within the business units without sort of operationalization requirements. They essentially took data, Excel spreadsheets, they ran analysis on that. They use what we call clickers platforms, sort of UI, nice UI, you throw in an Excel spreadsheet or a CSV, you start playing around generating a model and a report. And I think the operationalization and stitching the machine learning and AI into the business application came later. This is really where you started needing the engineering practices.
Yeah, and I think, this is exacerbated as organizations try to achieve scale and find that they're hitting so many stumbling blocks. And I think, on the next slide, what you'll find is, we have a name for this, right? And, I would say in spite of the numerous challenges associated with AI development in a business setting, many organizations are really doing some remarkable work but in the total absence of IT involvement. And we ask ourselves, why is that? And I think more often than not, your developers couldn't find the compute resources they needed in-house. And the almost ubiquitous availability of cloud computing in a convenient OpEx model has made it easy for teams to stand up what we'd call shadow AI. And I think the sprawl of shadow AI, especially in the cloud, is continuing oftentimes right under IT's view, maybe in the absence of an infrastructure strategy that could be enabling the kind of opportunities that we shared at the beginning of today's session.
Can you quantify the impact of shadow AI, or how much does it hurt the adoption?
Yeah, we've talked with Gartner about this at length, and they share some really interesting observations. I'll share two of them with you that kind of took me by surprise. And I see there's some commentary in the chat around this too. And one thing is they've done surveys, and one in particular found that 47% of models never make it into production, which I found staggering. So almost 50% of models that get developed that are intended for production actually never make it there, languish in prototype. A second impact that we've seen, Gartner also has found from respondents in enterprise that the average time to go from prototype to production is on average 8.6 months, which I also thought is kind of staggering. And I think these are the outcomes that you get when you have teams trying to go it alone or take a do-it-yourself DIY approach to infrastructure and platform. And so that's something that I think, your team and ours, the Iguazio and Nvidia teams care a lot about solving, so that's kind of my thought on that. Now, some, might not be ready for infrastructure that's optimized for AI. And there's a lingering question of why is that, and what's so, specific or necessary about AI infrastructure. So, for that, I think maybe we should go to the next slide. The reality, at least what we've found or figured out along the way, is that AI is unique in how it consumes resources, unlike maybe typical enterprise workload. And achieving fast time to solution on a model requires having enough computational power in combination with high performance storage to feed data sets into the training process with everything connected over a very high speed, low latency fabric. And these resources need to be designed in an optimal balance that ensures linearly predictable performance at scale. Without such a design approach, you could be throwing more and more capital at infrastructure, but getting minimal returns. And unfortunately, scaling AI doesn't simply mean getting as many servers packed with PCIe connected GPUs all stitched together. Remember, your data scientists want fast iteration speed on training runs, and as their models get more and more complex and their data sets grow, they'll likely need to parallelize their work over larger clusters in order to iterate faster. So, we believe architecture matters a great deal if you're building models to solve complex problems, and especially models that need to be parallelized over multiple systems. At Nvidia, we spent a lot of time in the data centers of some of the world's largest AI, quote unquote, hyperscalers, organizations that have vast CapEx and OpEx and resources to do groundbreaking work that many of us in the industry benefit from. And through that experience and our partnership with them, we've established what I'd say are some best practices that every organization, regardless of your size or embedded expertise, can benefit from. And they include things like, how to design racks in your data center for higher density and power demand, inter-system networking with ultra high bandwidth and low latency, especially in support of multi-system training. Using, for instance, 100 gig, 200 gig InfiniBand network fabric to support those kind of environments, making sure that your storage can support the high IOPS and ultra low latency needed for some of these complex models. And I guess, engineering the full software stack so it's optimized for multi-node cluster-aware training. So with this in mind, another question that often comes up is, where should you stand up this kind of infrastructure? Because there's a lot going on here. And, the one thing I'll say is that a lot of what we've worked on is modular approaches that don't necessarily mean you have to be anything close to a hyperscale data center, but you can actually start economically with a relatively small footprint, but using a design formula that will grow with you as you need to. So when you think about where to take this and where to place it, earlier on I picked on cloud a little bit, but I want to make something clear. This is not actually a cloud versus on-prem kind of discussion. I mean, in fact, both have a useful place in your development journey, but I'll also say that cloud is not the AI hammer for every nail. It's a great way to engage in productive experimentation, enabling your developers to get a fast start with a low barrier to entry. It's great at supporting temporal needs as AI development is starting to get underway, but many find that eventually, through ongoing iteration, their models start to grow more and more complex, consuming more and more compute cycles, and in parallel, the data sets fueling that training get exponentially larger. And this is the point at which costs escalate as the effect of what we call data gravity starts to become noticeable. And by this I mean more time and money is being spent pushing data sets from where they're generated to where the compute resides. And the speed bump and escalation in OpEx is an inflection point at which organizations start to realize that there may be a benefit in a fixed cost infrastructure that supports rapid iteration at the lowest cost per training run. And ultimately, I guess when your developers can train models without restriction or budget overrun, they'll eventually be more creative and probably build better models with higher predictive accuracy sooner.
So Tony, do you have any examples of customers that have moved between cloud and on-prem, and why?
Yeah, we see this pattern happen a lot. We were working with a company building an image recognition service for enterprises. They had started in cloud using obviously GPU instances, and they had a data set of several 100,000 images growing close to 1 million. And what they found was as the data set grew and obviously the model complexity grew for this service that they were building, they started to see a fear of failure in their developers, namely this this carefulness in terms of how they would kind of curate each training run because it was costing them money. They're spending a lot of work, effort, and cost moving the data sets to the compute resources and executing the training run, and then maybe like hours or a day later, they might find out that something was not set correctly or the run fell down. And so there's this feel of failure that they told us about. And that was exactly the point in time at which they said, you know, this probably just makes sense for us to land the compute resources next to the data. And for them, that was, you know, within the four walls of their data center. And this kind of follows that motto or that, you know, mantra of like train where your data lands. They kind of lived and breathed it. So what happened was they moved to a 4-way or 4 GPU workstation on-prem. They started to see a remarkable change in behavior of their developers because now it was like fixed cost infrastructure and they were iterating faster. And then as their models grew into, you know, multiple millions, the data sets grew into multiple millions of images powering these model training runs, they found that they needed to upscale to like an 8-way system, like one of our DGX systems, and the cost curve dropped down even further. And that inflection point and that trajectory that I just described is very typical for many enterprises who kind of begin their journey doing the right thing with productive experimentation in cloud. But eventually, they might decide that they need that fixed cost infrastructure. Now, I'm not saying that's true for every single organization, but you know, many will find that that holds true for them. So on the next slide, you know, maybe let's talk about, you know, I've mentioned this thing called DGX, and you know, at NVIDIA, we focused intently on how to bring the worlds of data science and IT closer together to realize the value of industrialized AI at scale. And, you know, it's important to set this up a little bit. We built this system to solve a fundamental problem we were seeing in enterprise data centers. Many organizations will find themselves with 3 silos of compute infrastructure, each designed for one kind of computational problem. Data analytics, model training, and inference, namely deployment. 3 kinds of planning, each silo independent, each silo only able to run what it was intended to run and nothing else. And this is creating inflexibility in many enterprise data centers. So we built the DGX A100 to solve this very challenge. This kind of universal building block supports the end-to-end AI lifecycle from data analytics to training to inference. And now, you know, our customers are enjoying essentially a homogeneous infrastructure, one server type, one appliance type that supports the entire lifecycle of AI development. So obviously for enterprises, it makes capacity planning incredibly simple and also lets you essentially build your own elastic AI infrastructure, as we'll see on the next slide. You know, on the left, and I'll just wait for the slides to catch up here. Yeah, perfect. And, you know, on the left, what we talked about is essentially inflexible infrastructure, right? That can't respond to business demands. The reality is most data centers find themselves in this situation when you're talking about AI at scale. On the right, we have what we'd call a DGX A100 data center. The left oftentimes is overspent on servers, or worse, they might be starving an AI workload. But you know, on the right, think about it this way. Imagine that today your infrastructure is almost evenly split inference and training, but most of your resources, compute resources, are focused on analytics as you do like data prep, early prototyping. And tomorrow, maybe the balance pivots heavy into training as we start scaling prototyping runs, less on analytics and inference. And then maybe in a couple of weeks when we have a model that's ready for production, we lean heavy into inference. All of this is happening on one infrastructure, one appliance type that flexibly adapts to demands over time. This is much more cost effective, we think, for modern enterprises that are trying to embrace AI. So if you think about the cost impact, let's go to the next slide. If you kind of do a before and after, on the left, we see that same legacy infrastructure that we modeled earlier on. And what you're seeing is approximately $11 million in training and inference infrastructure running on a mixed platform comprised of both GPU and CPU servers. You know, we'd call this maybe 25 racks of servers consuming a lot of power. And this may be the reality for many organizations. And for those leaning into AI infrastructure to support mission critical work, this might be where they end up. But on the right, we see a DGX A100 data center, 1 rack, 5 systems, flexibly offering the same capacity for training and inference, but also able to dynamically adapt to changes in the workload mix. And 1/10 the cost, 20th the power, a 25th of the space consumed. So it's much easier to acquire, faster to deploy, more agile in responding to demands, and faster from an ROI perspective. And on the next slide, if you think about this in deployment timeframe, this is oftentimes what the deployment experience looks like for many organizations that try to kind of go it alone or take a DIY approach to platform and infrastructure. They spend an inordinate amount of time building platform, integrating, optimizing, and the blue stuff is the sweat equity applied by people, oftentimes data scientists trying to build a platform in the absence of an IT infrastructure. The green is actually the capital investment from an IT perspective. So you see a lot of effort spent and a lot of money spent on things that really have nothing to do with data science or productivity. On the next slide, this is what happens when, you know, we take like a full stack AI infrastructure approach. All the non-value added time and effort and money spent disappears, and you get one additional benefit. What you'll see on the next slide of this animation is that you get this dramatic compression of your timeline. All the non-value add work goes away, which means that you can iterate faster, develop better models sooner, drive up accuracy, and get a better product or service out the door to your customers sooner in a fraction of the time. So, you know, on the next slide, just to bring something home, you know, what we've talked about here, you know, we talked about the extensive life cycle or time cycle that many experience trying to get models out the door, the low success rate. This is all a great reason for why organizations need to embrace MLOps, why they need to be looking at Iguazio as a way to streamline and industrialize their AI workflow. We think that many enterprises are apt for this message. As I think our listeners are already aware, this is the intersection that we recognize is important to solving the challenges that we talked about, namely having this DevOps mindset and rigor applied to AI experimentation and model prototyping.
So what would you looking for to generate success? What's the matrix for success?
Yeah, I think, you know, it's a combination of things. You know, platform is key here, but, you know, there's some table stakes, right? Being able to have better control and manageability of, you know, users, data sets, experiments, model versions, being able to add rigor to that process of releasing prototypes into production. And I think it's a combination of all the kind of the platform virtues that, you know, Iguazio brings together, combined with the right kind of purpose-built infrastructure underneath it. And by that, I mean, you know, the kind of things we've designed for in DGX. And all of that, I would say, combined with kind of a top-down leadership perspective that champions this evolution, because for many organizations, this will be very new. And that's why, as you see here on this next slide, we think, you know, IT leaders are key to this. This kind of decision-making does oftentimes happen top-down, and hopefully what our attendees are hearing today is that if you're in IT, you can actually be the champion for your company's AI success, but you'll need an infrastructure strategy, one built on MLOps and the right kind of infrastructure underneath it that'll help you avoid running up OpEx on DIY approaches, and obviously one that'll help you with the right architectural choices to centralize compute, talent, process, technology. And really this is where Iguazio and Nvidia are strategic partners delivering value. And I think at this point, I think it'd be a great time to hand it over to you, Yaron, to continue our discussion.
Q&A, so maybe before I start, we can address some of them. The first question is, where are we in the market adoption of cycle of MLOps platforms? And I know, Saar, probably you're talking to Gardner more than I do, but I think we're very early in the adoption. And that relates to the second question, which is, I see many data science and MLOps platform vendors like Dataiku claiming, a lot of customers. I'm surprised the claim of enterprise AI in production is still immature. I think it's critical to understand what's the difference between what companies like Dataiku started delivering, or Domino Data, or other companies. It's not really MLOps. I know, when cloud started, everyone called their solution a cloud, but MLOps is really more about automating the production aspect, while the original source of the data science platforms were more in the research part, was, give me a bunch of CSV files or some input data, let's build a model, let's do data preparation, and then you have a report, a nice report, or maybe a model that goes behind some HTTP endpoint. This is not necessarily what we in the industry refer to as MLOps. MLOps is really about, think of the equivalent of like CI/CD, full automation, scale, etc., for machine learning, and essentially plugging the results into a real business application, whether it's a fraud detection system or recommendation engine, not necessarily leading into a report or something interactive. And so I think more and more vendors are now hopping on this MLOps wagon, and we're obviously one of them, but it's still a nascent market. I don't know, Tony, do you have anything to add on that?
Yeah, I think definitely it's evolutionary. It's a path and a direction we see many organizations embracing. Unfortunately, many are still finding them in the early days of DevOps themselves. So I think that compounds the problem, and hence why we think that this is still kind of a journey that many organizations find themselves in.
Good. So with that, it's actually a good segue to my slides, and we'll continue with the rest of the slides, and the slides and the video are going to be available. But I think it's this slide is actually a good segue from this previous question that I answered. And also Tony talked a lot about the complexities of building enterprise AI or building a solution into production. And we've seen that constantly with customers telling us, it takes us at least a year, not just from this tweet that Tony was showing, but actually I was talking to a customer last week who was saying, before we used MLOps and your solution, we essentially delivered one application a year. And now they're delivering every 1 or 2 months, they're delivering a new application because they applied automation. And when you see what does it take, what does it mean? Okay, I have a model in the lab, I did my research, I have a POC, I can prove my point. Why does it take a year to productize it? So you can see here the individual steps that you need to take in order to productize a model. The first thing, you take this piece of code that some data scientists wrote in Python, you need to package it in a microservice, in a Docker container, etc., with all the package dependencies, etc. The next thing, usually the data in production is not the same scale of what you're using for training, or you have requirements for dealing with more algorithms or more sophisticated algorithms, or dealing with larger data sets. So you need to start thinking about scale out. I don't know about any data scientist that his notebook is thinking about how to scale the workload and distribute that. And then you're stumbling into places. We went, for example, into a customer, he was going into production. He had to serve 500 requests per second average for his requests, very complex sort of ML models. They only did 5 requests per second. This is what they managed to do on a 4-node cluster. Yes, they can do a 400-node cluster and meet 500 requests per second, but potentially by applying caching and using GPUs instead of CPUs, etc., this is how you can get it up. And we eventually managed to use 2 servers with a couple of GPUs attached to them that essentially made them reach 500 requests per second. So this is just an example that someone that writes code in development doesn't even think about how to optimize, how to do caching, parallelism, and all those tricks. And when you're building stuff to production, again, you have to instrument it. You have to apply monitoring, logging, explainability, versioning for everything that you're doing, security around access, security for data. And finally, you have to think about automation, CI/CD pipelines, rolling upgrades. You want to update the model, you don't need to take everything down, you just update the model. Maybe you need to update the feature engineering code. Maybe you have an ensemble of multiple models. machine learning, everyone thinks of it as, you know what, I have a model, I'll put it behind an endpoint. But we see many customers, we're dealing with a customer doing like NLP processing in financial services. He has like 8 different models in a single serving pipeline with sort of dependencies and all sorts of things. So those things become more and more complicated, and managing them becomes more complicated. So essentially what we want to try and do is automate this workflow, because I think it's even more severe in a data science world where the originators of the code are data scientists. They're not software practitioners. They're not designed to do software. They're designed to build algorithms. So it even increases the emphasis of automating this flow. So with that, Iguazio has a full-blown platform. I'm not going to focus too much energy on explaining it. I'll just demo a use case. But in our platform, we have on one end all the data layer with a very high-speed database and data processing engine that we've built along the years. You have a full managed stack of services based on the best-in-class open source frameworks in the 3 different disciplines. Tony spoke about silos: data engineering, data science, DevOps. So essentially, the advantage of using something like Kubernetes with a set of managed services on top of it, that you can apply one solution to all those different disciplines, like Spark and Presto and Dask, etc. For the analytics folks, you can apply, PyTorch, TensorFlow, etc. for machine learning. And you have a lot of frameworks that are all oriented towards the automation and MLOps and DevOps, like Kubeflow, Grafana, etc. And Nucleo obviously as a high-speed serverless engine. So we try to wrap all those services as a managed service, sort of serverless with abstraction and automation behind it. And on top of it, you have even higher level of abstraction. We'll show some of it around like real-time feature store, of how to essentially build, one of the main challenges, you build a model, you have to serve it features, but how do you engineer features fast enough in the serving layer? This is really where sort of online feature stores come into play. There's machine learning lifecycle, model management, artifact management, data set, feature management, experiment tracking, and there is pipelines. And usually there are 2 separate types of pipeline. One pipeline is the sort of development pipeline. This is where platforms like Kubeflow are very strong, or Airflow in some cases, where you essentially create a batch pipeline of one task after the other. It's really more towards the development side and research side. But you also have real-time pipelines, which are usually using like high-speed communication, stream processing, etc. This is where you actually do the inferencing, feature engineering, ensembles, drift analysis, etc. So you have all those things in essentially single managed platform. And together with Nvidia, we're building, sort of think of it as an appliance. And Nvidia, in some cases, other joint partners like NetApp and Dell and others, you can take servers, whether it's DGX or DGX certified, or servers with Nvidia cards, or sometimes you also need servers without VMs for other tasks. You have Kubernetes as sort of a orchestration layer, and you have a real-time data layer that allows you to essentially create a single system image across all your computation. And on one end, you can create tasks and jobs for anywhere from research through Jupyter, VS Code, PyCharm, etc., or just launch jobs or create services and pipelines. On the other end, you want to track everything. You want to monitor anything from the resources up, anywhere from the utilization of the GPUs and the utilization of your systems, and that you're not wasting money, or how much is a project going to cost me, all the way up to monitor experiments and monitor models and drift and things like that. So essentially, again, having one platform that allows this elastic scaling, which also allows you much better cost efficiency, because if I can have one set of resources and dynamically schedule different workloads on the same set of resources, that allows me to save huge amount of cost on one end. On the other end, if one data scientist wants to run a job now on 20 GPUs, he can do that, because the minute he's going to finish his job, all those resources are going to go back into a pool. Someone else can use it, versus taking a virtual machine, giving it to Joe. Joe goes to lunch. No one is using it, and you're wasting money. So we want to apply optimization and dynamic resource scaling. And one of the secret sauce for that is essentially moving into a more of a serverless mindset. So serverless is not a new concept. We have Amazon Lambda for many years now. but we've also created a set of new serverless engines which are more oriented to backend workloads, high-speed stream processing, high-speed serving, integration with GPUs, high-speed training and data analysis. And those frameworks provide you a few main benefits. One, they automate the entire flow from code, anywhere from a notebook, as I'll show in a minute, into a fully managed service. Fully managed service is not just the container or the pod in Kubernetes. It's also the storage attached to it, the logging, the monitoring, the security associated with it, etc. The other thing which is very unique to some of our solution is the increase of performance because of a sort of real-time technology built around those kernels for serverless, unlike some of the traditional serverless engines. In some cases, you can actually speed up the performance by at least a magnitude. There's actually a pretty nice blog that we've done together with Nvidia on how to use Rapids with Nucleo together. In that benchmark, we actually achieved like 30x higher performance compared to just running analytics on a simple Python engine. And that's a lot of it is due to parallelism aspects and the more optimal use of the GPUs. And there are other things there. We don't necessarily just stop with traditional serverless concept, but you can actually create distributed jobs which are like deep learning jobs or machine learning jobs or data analysis jobs that require really distributed processing and distributed data, not just sort of a simple load balancer in front of a job. And you can benefit from sort of a marketplace where you don't really need to develop all your functions. You develop them once, someone else can use them. Or maybe a data scientist develops a function and someone else takes that function and uses it or extends it or improve the performance. So with that, I want to show you a demo of a full-blown application to essentially show what is the potential of running like AI in the full scale with all those features. So let's take an application. Someone wants to analyze stock data, stock information, but he doesn't just want to look at numeric data. He wants to actually process news about individual stock. I want to see someone is writing some article about Google. I want to analyze the sentiment because it's probably going to impact the behavior of my analysis. So for that, we need to create an NLP model. Today, the most common way to do that is using something called BERT, which is for pre-baked NLP models, and you want to extend it to your use. So the first thing that we need to do is take some reference data, some reviews, like movie reviews or something to analyze the sentiment. We want to base an NLP model. We want to run training and testing in an automated way and throw it into a model store. And I'm going to show that in a minute. But that's just the first phase of development. The next thing I want to do is I want to actually use this model in a real application. So what we're going to do is we're going to use two serverless functions. By the way, all this demo is open source, and I'll send the link later. So we want to actually use two different sources for our real-time streaming. We want to use essentially scraping Yahoo Finance data in real time, which includes real-time market news and real-time stock ticker data. We want to take this news data and we want to run it against our BERT NLP model. And we want to take the enriched data of sentiments per stock and the real-time stock information and store it in a real-time feature store, which comprises of like a news stream and sort of real-time and time series analysis of stock. Now we want to use this stuff and show and visualize that. So you're going to see that once we write it to the feature store, we can do two nice things about it. We can also do more things if we want to, but for sake of demo, we're showing a real-time dashboard that shows us the news feeder on one end, which is also, there is sort of a function that creates HTML and backend for the news feeder view. And also we want to do interactive analysis on the stocks, on the real-time stocks data in combination with sentiment information. And we may want to do it with different analysis tools, whether it's through Pandas or Spark or Presto, etc. So that's essentially the demo that I'm about to show you guys. So I'll go into Iguazio platform. I'll open through the Jupyter notebook of the project, sorry. So the first thing that we need to do, let me just refresh here. So the first thing that I need to do is essentially training, sorry, for the internet. So what we need to do is do the training function. So the training function is essentially, again, a typical TensorFlow code running a BERT model training. I'm writing it in a notebook. And when I want to actually run the notebook, which is building that model, I can test it locally, and I could just go and deploy this as a job in the cluster. The central concept in all those functions, you just call something called code to function. It translates it into a microservice. You can tell it how many resources you need. In this case, I need a GPU. And I could just go and give it a file mount to place all the data as a result. And I can run this, and I ran training, and now I have the model in my hand. I'll show you in a minute we can actually do it as part of a complete workflow. So now that we have a model, we want to build the entire real-time pipeline. So the first thing that we want to do is the real-time stock scraping function. So this is essentially a function that goes to Yahoo news site, reads the HTML, parses, and takes it out. We used to have another demo that used some sort of tokens, but for sake of simplicity, it's easier to just go and scrape Yahoo data. So I have a function that essentially goes to Yahoo data, reads all the information per stock, price, volume, etc., and writes this data into the time series layout on our real-time database, and updates some tables about the stocks with real-time information. So this is a relatively simple function that grabs, and anyone can use it for his own purposes, scrapes data from Yahoo data, and I can test that function locally in my notebook just to verify that it works. Once it's verified and it's working, then I'm just going to, again, code to function, make it a microservice, deploy, will essentially make it a real-time function. So the way for me to move something from my notebook into a full production artifact is simply calling those two things, make it a function and deploying it. And if we want to see how it looks like in the actually Nucleo UI, Nucleo again is open source. So you can go into that function. You can see the code. It was essentially exported from the notebook. So there is a comment here. It could have configurations with CPUs and GPUs and volume mounts and other things. It can listen on various triggers. In this case, it's a cron job. So every few minutes it goes and scrapes the internet, but we can also trigger it from other things like Kafka or HTTP, etc. So now we have our first function that does stock numeric analysis. The next function will essentially go and read the Yahoo news and run the BERT NLP models against it. So again, there are a few pieces of code here that essentially goes, scrapes Yahoo website, calls the endpoint that does the sentiment analysis, gets back the response, and takes both the data, the news data with the sentiment, and writes it into the feature store in real time. So now we have two functions that what they do in life is just take the data and writes it into the feature store. Some of it is news, some of it is sentiment, some of it is numeric data. And I also have a real-time dashboard, because those functions, there's another simple notebook here that essentially builds a Grafana dashboard for all of those values. So I just run this notebook, it will generate a Grafana dashboard like this, which is essentially giving me the stock information, giving me per stock. I can essentially change the stock. For every stock, I will see the price, volume, sentiments. And I also have this news feeder that, remember this microservice that just generates nice tabular form from the stream. So very easily, I just generated a real-time dashboard. from all the data of news and sentiments and real-time market data. But let's go into something slightly more interesting. We want to take this real-time data and start playing around with it using our notebook. So what we can do, again, we mentioned that we have Spark as part of the solution and is directly attached to the data store that, all the real-time ingested data is actually going into a real-time data store. And Sparks essentially can view that data store as if it was a simple data frame. So you can just go and create sort of a Spark query and tell it, go read this table. And it will just show you the table as if it was something that someone did ETL with, but this is real-time data that just came from the market. I can also run interactive SQL using another query engine called Prometheus, or called Presto. So I can just do a select statement and get the same real-time data through a standard SQL interface without running anything, without needing to authenticate myself. It's all under the hood as part of the managed platform services without installing Presto or Spark. And the next thing I want to do is essentially go and read the data as a feature set and not necessarily through a SQL querying. It's time series data. So I want to build a feature vector that comprises of sort of keying based on time and symbol. And then I want to have all those different features that we discussed, price data, volume data, sentiment data, etc. So I can just go with a single command. I essentially created a Panda data frame that is the feature set that I need for analysis or for training. By the way, this engine also leverages Nvidia Rapids, which is sort of an accelerator for analytics workloads in the GPU. And once I have this data set, I can just start pivoting it and show real-time market volatility based on all of those matrix. And if I want, I can just go and read the stream with all the news that I've seen. So going back, you've seen that how I can just create few functions, deploy them as a real-time service. Those functions will start pumping data using real-time machine learning models. We'll use, for NLP, we always use GPUs because that's the most cost-effective solution. So both the training as well as the serving here use GPU. For data analysis, also in many cases, using the Nvidia Rapids library, it's useful to use GPUs. We have some, we've published some benchmarks together with Nvidia Rapids team, showing a significant performance boost by moving analytics workloads into GPUs. There's also a cool database called Blazing SQL that's using sort of Nvidia GPU instructions to run sort of analysis. So those are things that you can do. So again, we built a complete solution that has all the aspects of data ingestion, model serving, feeding everything to a real-time store, and essentially creating different views on that real-time store. Some of them will be real-time dashboards, some of them will be real-time alerts, some of them will be interactive work of data scientists or business analysts. And we've also done on the same system, we've done the training, and everything is managed through a single view. I didn't show another nice thing here is, first I also mentioned that we can essentially create a full-blown pipeline. All the things that I built here as manual steps, I can go and create a project. Let me go here. I can just create a project, which is sort of a workflow that imports all those individual functions that I had in the individual notebooks. I may also want to have a library function. The sentiment analysis function is something generic, so I don't need to write it. I just load it from a marketplace. And then I could write essentially just a pipeline workflow that says, do the training and then go and deploy this guy and deploy this guy. And if there is if you need to do training, do this. You can actually do conditions. This is based on the kubeflow sort of processing workflow. So you use the kubeflow language, but instead of working with YAMLs and Docker containers, you would use a function, which is much simpler to do. So you can do those things. And now another thing that we mentioned is that we ran various experiments. We ran training. So when we run training, we can go back into ML Run UI and we could look into the, for example, training job, and we could see all the information of that training job logged in automatically without adding any instrumentation to our code. We can see all the statistics of our and all the information and metadata of our execution. We can see the inputs used for our model creation. We can see all the artifacts that were generated from the training. Sorry for that, we disconnect. We can see the results of the training, and we can see the logs and everything. And all the versions, if I ran it multiple times, I will see all the versions of every execution. So that's, again, in a nutshell. So to summarize, what we've seen is how we can build relatively complex solution that really built of many small services and microservices and functions. This solution could be built in days using those set of tools that fully automate the deployment process. Okay, with that, let's see if we have any more questions.
So let's take a few quick questions from our Q&A panel here. The first one is, how does one get started with an AI project and who should be involved?
Yeah, maybe I'll take a swing at that first. This is really a team sport. At least that's kind of like the way we like to think about it. As I mentioned earlier in my comments, oftentimes there's an inclination to put a lot on the backs of the data science team, but really, this is the combination of business analysts, data scientists. If you have a data engineer who can help with kind of building or fueling the data pipeline, obviously people from the IT or DevOps side of it, and certainly someone from an application development perspective, so you can productionize your model. I think these are all useful competencies that can come together however your organization is structured, depending on kind of who has those hats. But it's really important, I think, to have those, and depending on the size of your organization, you may need kind of an exec sponsor. If you've not been undertaking projects like these before, it's so critical to have someone who can be a champion or visionary for the work your team is trying to do, helping you marshal resources for that first use case, that first application, which is hopefully like low-hanging fruit, something pragmatic and practical that has business impact. And oftentimes the team you assemble builds a lot of muscle memory around how to take models into production, and that becomes like a flywheel, enabling you to get more and more resources, budget, and so forth to tackle bigger and more complex projects.
And Tony, I think the other question kind of leans into that, and this is, how can enterprises justify an investment in AI infrastructure like the one we're discussing? So after we've got the right team in place, how can we show an actual ROI in investment?
Yeah, there's, I know for some it may be off-putting when we talk about the kind of infrastructure that we see in enterprise data centers. And oftentimes what we find is that organizations have actually enough accumulated investments in discrete silos of infrastructure that they can easily justify what we liken to as a machine learning center of excellence. The idea that if you were to consolidate all these silos and look at the net total amount of resources and human and working capital that's being applied into AI, you'll actually find you justify even an entry-level system in your data center that can handle all of it. The ROI is really important because really undertaking these projects should be tied to something that has discrete business value. Namely, you're hopefully doing this because you're either trying to save money, reduce costs, or you're trying to create a new revenue growth vector for your business. And those things, you shouldn't really be undertaking any kind of AI project, I think, without having a clear line of sight to what the mission is and what you think the tangible outcome will be. I think oftentimes if you look at oftentimes a few percentage points of reduced inventory in your retail operation, or reducing customer churn by, a certain percentage points. These things have tangible value, and if you set those against the cost of infrastructure, that ROI factor becomes a lot easier to explain to people.
That's very true. That's a great point. And Yaron, one question here for you from the audience who's viewed the demo. They're asking whether these demos can be shared, or if they're already in GitHub. Is there any way to?
Yes, we have many different demos. This is sort of new. I shared the link in the chat. We're working on some tweaks on that. It does work, but we're going to sort of minimize a few of the notebooks further, probably tomorrow. But it does. You can just go and look into the Git. There's also another Git with many other demos which are pretty interesting, like churn detection and network operations and others.
Great, thank you. And since we are towards the top of the hour, I'm just going to go ahead and share with you that we have some additional MLOps resources. So if you enjoyed this webinar so far, we invite you to visit our MLOps page on the Iguazio website, and you can take a look at all of our MLOps videos, at previous sessions of the MLOps Live Webinar Series. We have Netflix, we have Uber and Spotify and many other practitioners who have shared their insights on MLOps and getting data science to production, and we have many blogs on this topic as well. And we'll share the poll results with you now. So the first question was, what's your biggest roadblock to deploying AI? And most of you have said the right infrastructure, which is no surprise if you were following everything that was discussed here today. And the second question was, to what extent are you using GPUs in AI development? And most of you are not using GPUs at the moment or using them for light experimentation, which is very, very interesting.
So Tony, you need to do more work on those.
Yeah, we'd love the opportunity to help folks see how they can speed their AI development aided by GPUs. So definitely talk to Nvidia, talk to our partners, talk to Iguazio here, and we'd love to help you get started.
Yep, looks like many people are keen to do that. And with that, I would like to thank our speakers, Tony and Yaron, very, very much for this super interesting session. And thanks everyone for joining us and for asking so many questions. We invite you to continue the conversation on Slack. We'll share the link in the Q&A box in a moment again. And we'll be happy to answer any additional questions that you have and those that we didn't get to due to time constraints over on our Slack channel. So thanks again, Tony and Yaron, so much for this great session.
Thanks for having me.
Thank you.
Thank you.